Hey, AP Physics people. So this is a question about a robot launcher. So it's a pretty cool question. Um, in the question, the robot's going to shoot a projectile and it's going to go a certain distance and it's a competition. So they're trying to hit right at that spot. So I like this question. It's pretty good. So if you look at it, it says you got your robot launcher. And, I'm going through and reading this part and just kind of piecing things together. So I'm going to summarize what this says, but during the AP test, you would really carefully want to watch this. So it says you have a robot launcher. Initially, it shoots a cannon, and if you're at height h and you're going at speed v0, it's going to hit right at x equals d. So in this, it says that the robot launcher, that the height can be adjusted, the velocity can be adjusted, but it's at a fixed x equals 0. It's not going to change this. Okay, so now here is the first part of the question. On the axis below, sketch on the graph the horizontal and vertical components of the sphere's velocity v as a function of t. All right, so we're going to come down here. We're going to do the x component of the horizontal velocity and the y component of the horizontal velocity. But as it's going down to or I shouldn't say down, as it's going, time is going to t. All right, so let's look at this. I'm going to do this in red, so let me switch the color here. So if you look at this, no matter what, it's always going to have the same horizontal velocity. At any point here, it will always have the same v0x. It doesn't change because there's no acceleration in the x direction. And we're saying that this is that there's no air resistance. If there's air resistance, then this v0x would change. But the v0x doesn't change because right here it has all, I should draw it the same length as this, but it has all horizontal velocity. Oops. Okay. So let's come down here now and let's look at this. So erase this. Okay. So we just said that the horizontal velocity doesn't change. So the whole time it's going at a constant v0x. And I could even be more specific and say that whatever value here that this is at v0, if it launched at 4 meters a second, well, the horizontal velocity is going to stay at 4 meters a second if there's no air resistance, because gravity doesn't pull it in the x direction. So there's nothing pulling or pushing it, so it's going to stay at that velocity. All right, but the vertical component, let's go back up here and show the vertical component. The vertical component, this one does change. So at the very start, let's think about it. What is that vertical velocity? If you think about it, it's 0. Like it has to be 0. Like there's no vertical velocity right here. It hasn't started to fall. But as this thing starts to fall, it starts to pick up vertical velocity. And look at here, like we're going to really have to look at this. It tells you that if you're going down, that's in the negative direction. So we have to say that, like, okay, this is in the negative direction. All right, so the vertical velocity is well, we should say decreasing. It's decreasing or increasing in the negative direction. And what's that due to? What pulls something down? Gravity. So gravity pulls something down. So at the very start, we have that it's at 0. There's no velocity in the y direction. But then it keeps going down, and this is arbitrary. We don't know the exact we don't know what the exact velocity would be. Like we could solve for it in terms of h and v0, but we're just going to put that. We don't need anything on these axes for that question. All right, part 1 is done. So we'll go through and look at the scoring rubric in a second. But now let's go to the second part of the question. Now we're getting a little bit more complicated. So the scenario goes now, so once they get to the competition, uh-oh, the thing broke and now it's stuck at h/2. So we know that the height is h/2. But we can still launch at these two velocities. We can launch at v0 or we can launch at 2v0. So before we get started, so this is a paragraph length response. Before we get started, even if you, like I'm going to do the math out and show the equations. That's the way I like to think. But you can think of it as if you get down some basic points here, then you'll be able to score some points. Like for example, let's think about this. If this now was h/2, and I'm just going to change it here. So let's say it's h/2, and you're going v0. Well, if it hit D when it was at h, well, at h/2, it's going to go less than. But we don't know yet if it's going to go in that 2-point region. We're not sure. We're going to check that out. And if it was 2v0, well, we have to know that it's going to definitely go farther than this one. We're not sure if it's going to land, though, in the 3-point section or not. So since things are changed, though, we know it's not going to hit, they're not going to get this 4-pointer. So let's see, is 2v0, will it go farther or will it not? So I'm going to do some of the math set up here. All right, so let's look at this. So let's go to a blank page and let's look at this. All right, so we have our height. And our height is, let's go black again. Our height is h/2. All right, and I'm trying to solve for my delta x. So I can come over here and put, let's put like the original. So we know that the original one, that delta x was equal to d, and this was the 4 points. That was the 4-point region. Okay, so let's look at in this, I'm going to put that this had time. And really, like the time, this is what we're going to be looking at. If you put down as a basic point that the time for h/2, like these times, this time right here, is definitely going to be less than this time. I can call that time 1. Right? It's h/2. The time in the air is going to be less. It's launched horizontally. So let's go through and let's calculate. Let's do what T1 would be. Well, I need to know a little kinematic equation for this. So it's on the formula sheet, but we should really practice, like, what's the time in the air for something launched horizontally? And it doesn't matter if it's, like, this was back to the scenario that we probably talked about in class, of if you have a bullet, if you just drop it, or you fire it, as long as it is only due to gravity, these times are going to equal both times. It doesn't matter how fast it's moving in the x direction, they're both going to fall at the same rate, because it's still gravity that's pulling both of them down. There's nothing pushing or pulling it in the x direction. Okay, so let's look at this time. So I need to know a kinematic equation, and this kinematic equation that I'm going to use Usually we use delta x, but since this is in the y direction, I'm going to use delta y is equal to v0y t minus 1 half gt squared. Okay, so that's my kinematic equation, and you might need some refresher on that, but this tells me that how far or how long, like I can see that there's a time in here, and I'm going to be able to solve for the time for it to fall a certain distance. Well, the first thing, we know that v0 in the y direction is 0, so that cancels out. And you see a negative here, and you might think like, oh, this negative is gonna come in play. But they're both negative. Delta y, since it's falling down, it's going to be negative too. So we can just kind of ignore the negatives here. All right, I'm going to do a little algebra to solve for t. So I'm going to skip the steps. Hopefully you guys can sit down and do the steps and figure out the algebra behind this over g. Okay, that's the time for it to fall. And the only thing it's dependent on is gravity. So we'll call that T1. All right, so we'll do T. So this is T, and the T's are going to be the same for both scenarios. So we'll just write it in black. So now we have that our time is equal to, well, we still have 2. Right, we still have this 2, comes from the 1/2 up here. But now my delta y is divided by 2. So I'm going to put my delta y over 2. Okay, which that is equal to square root of delta y over g. Okay, so we have t and is this, and this t is this. Okay, so one thing that you might want to do here to see, let's compare the times. Well, this one, I'm going to pull this square root of 2 out. A little bit of math there. You have to know that, oh, I can pull this square root of 2 outside of the equation. And that these are equivalent. So now if you look, my t1 is going to be equal to square root of 2 of my other t. All right, and that's equivalent to this. I can rearrange this thing. And that is square root of 2. Okay, so my time, we said it's going to be shorter, right? And so it is shorter. It's the regular time. I would have to divide by square root of 2. And you have your calculators, you can do that. The square root of 2 is 1.4. And then if you divide that, was at 0.7. So I'm going to write that down here and write it in black. But we can write it right here. So t is equal to 0.7 t1. My new time is going to be 0.7 times my original time. Okay, so let's come down here. I'm going to write in, let's write in blue now. So let's do for this scenario V naught. So this is for V naught. So we're going to shoot it at V naught. So we need to see how far is this thing going to go, and if I shoot it at just the regular V, your initial velocity. So let's think about this. Well, this is the time it took it to fall, but how far will it travel? And we should think of like, oh, well, how far is it going to travel? Well, in the x direction, v0 stays the same in the x direction this whole time. So it's constant velocity. It's constant velocity. All right, constant velocity with no acceleration, we have a really easy equation then. Vx is equal to delta x over t. All right, so with this, let's solve for delta x. So I have delta x is equal to v0, and I can put the x there. It's not super important that I have that, times t. All right, well, remember that t is equal to 0.7 t1. So we'll say t is equal to 0.7 t1. So let's come over here and rewrite this. So if I have this, I'm going to say, oh, my v0 x is equal to 0.7 t1. All right, so if you think about that, well, v0x times t1, v0x times t1, that was just d. So this right here is d. So what I get is I have my delta x is going to be equal to 0.7 times d. 0.7 times d. That means, so 0.7 d is in between 0.5 d and d. So that means it's going to end up somewhere in this region. So I score 2 points. So this one right here gets 2 points. All right, let's look at now what happens if now I have the same height, but I go to v0x. I start shooting it off at 2 times v0x. Well, again, now my velocity, if I have 2 v0x, that's my velocity, and velocity is displacement over time. I'm really looking for this delta x, so let's rearrange this in terms of delta x. So I get 2 v0x times t. And now let's write this in terms of this t is still going to be 0.7 t1. So I have 2 v0x, and now my t is going to be 0.7 times t1. All right. Okay, v0x times t1 is d. That's d. So what I have here is I'm going to have delta x is equal to, well, v0x times t1 is d. So I have 2 times 0.7, and then I have d. Okay, well, 2 times 7 is 14. So 2 times 0.7, 1.4. 1.4d. Okay, let's look at see how far 1.4d would be. All right, this is 1.5. This is 1.5. So 1.4 is going to be right around here. So 1.4 right around here. That means that this one gets 3 points. 3 points. So clearly, if we're going for the most points, you would want to fire it at twice the speed. Okay, so let's look at the scoring rubric and how you would actually score points here. So let's check out the scoring rubric. See how many points you guys would have scored. All right. For the first one, we had the first question, 2 points, 1 point earned for the horizontal line. So we had that. So cool, 1 point. 2 points is earned for starting at 0 and coming down, having a constant slope. So we see that it's a straight line. It becomes more negative. So those are the first 2 points. Now let's go to part B. So part B. All right, so you're scoring points here, even though you didn't have to do all that math to get some of these points. So 1 point earned for a statement that a sphere launch from h/2 will result in a free fall time that's less than t. We did it mathematically, but if you just have a statement that, okay, now the time for it to fall is going to be less, you'd score a point. 1 point is earned for a statement that indicates that if the sphere is launched from the original speed v0, that the distance the sphere travels hitting the ground will be less than d. All right, we did the math out and we found that it's less than d. But if you just write down, oh, like it makes sense that if the time is less, has the same initial velocity, it's going to fall less than d. There, you score a point without doing all that math that we did. Now, 1 point is earned for a statement that indicates that with the half the height and a speed of 2v0, the student can no longer earn 4 points. So we're saying that, oh, with v0 or 2v0, that it's not going to hit the bullseye. All right, that's it's a good statement that we can get just with some logic. So we get another point for that. All right, now here's where you would have to justify it. And like we would have to have a statement that indicates that if you have 2v0, you line up in that 3-point zone. So we did the math for that. And then the last one, 1 point's earned for a logical, relevant, and internally consistent argument that addresses the required arguments or questions and follows the guidelines described in the published requirements for a paragraph length response. All right, that is wordy, but that essentially is if you can draw it all together and you can justify it. So really for this one, it's like showing that math that justifies your response. So in ours, the way I would do it is I would actually show these equations, and the equations are they are a justified explanation. So you're allowed to put those equations in, and you're allowed to state that. So if you want to take the time to read this example response, you can do that. I'm not going to do it with you, but you can see that this one will answer the question. It will show some basic physics behind it, and then it will draw it all together with a statement that sums up the answer. That we get 3 points if we have 2 times v0. Okay, hope this helped, and we are just going to continue doing free response questions because these are challenging, but we can get through it. All right, good job, team.